We're still on chapter 24, Charles Darwin and Evolution. Are you going, Asher?
Mm-hmm.
How good are you? And we're talking, let's talk about Darwin saw, well, I tell you what, let's just review here what we talked about yesterday. Darwin came on this boat called the Beagle. He left Great Britain, traveled around South America. They studied South America. They saw a lot of things there. He went to the Galapagos. He saw a lot of different species on the Galapagos. It got him to thinking that organisms might change. He had a lot of reasons for thinking that. One of them was he saw these iguanas. The iguanas that he saw in South America couldn't swim. And they didn't eat seaweed. The iguanas that he saw on the Galapagos could swim. And they were bigger, and they were heavier, and they had longer claws, and they had flatter faces, and they had wider tails, and they could swim. Darwin thought that those iguanas on South America might have changed into these iguanas on the Galapagos. There's me with iguanas. Cute iguanas. Swimming iguana. Me with sea lions.
Where is this?
Galapagos Island.
Could you pet the sea lions?
Yeah, they didn't want you to pet anything.
They all have little dogs.
Darwin saw these fossils of giant, what are called glyptodonts in South America. And they looked a lot like modern armadillos. Glyptodonts are these big creatures. Armadillos are these little creatures. They used to have these. Now they have these. Darwin thought that these might have changed into those over a long period of time.
How does an animal get smaller?
Ah, that's a good question. We're going to talk about that. It's this process that he called natural selection. But when times are tough, when there's not enough food, the small ones tend to survive better. You know, if it was just me and Jason around and there wasn't a whole lot of food, who do you think would do better?
You.
You want to get food?
Yeah.
Now?
Yeah.
Yeah. I would probably do better than Jason because he's so much bigger than me. He needs more food. So it would be survival of the fittest. Now, if he had many boxes and bags of food, do you want student to carry that for you?
I've got some guys that are going to help me and just trying to get it under way.
Well, like right now, did you want?
Okay.
No, you're good.
Thanks.
You're welcome.
Survival.
We did pretty well there. Yeah. So, that's me with the glyptodont fossil. What about the tortoises? So we didn't talk about the tortoises yesterday?
We did.
Oh, we did?
We did by the long necks and the short necks.
Yeah. Yeah, he saw some tortoises on some islands with long necks, and on most of the islands they had short necks, but on a few islands they had the long necks. And Darwin noted what there was to eat on the islands with the long-necked tortoises. And as it turns out, the long-necked tortoises are only on islands where the food is up high. Tall cactuses. So Darwin thought that the tortoises might have changed on that island to evolve longer necks so they could eat the food. Look at that neck. I love that tortoise neck. That's me with one of the tortoises. He's checking me out. He's going, hey, is that Darwin? I remember, no, that's not Darwin. You know, these tortoises can be 150 years old or more. It's possible that there's a tortoise around that was there when Darwin was there. 200-year-old tortoise. How cool is that? They don't really know how long those things live, but they estimate up to 150, maybe even 200 years. Check him out. They were just crawling all over the place. Tortoise shell. Me and a tortoise shell. Teenage Mutant Ninja Turtles. They're big shells. Those are the giant tree cactuses that are on the islands where the long-necked tortoises live.
How come there's like no grass in any of these?
There's not much rainfall on this island. It happens to be in a location where it just doesn't get much rain. That little amount of rainfall, no grasses or anything grow, only cactuses.
Wait, are their necks long enough to eat those?
No, they wouldn't be able to eat these, but they could, these things had to grow to this size. So when they were shorter, they could be eaten. So the tortoises evolved these long necks, and they actually, you can see them, they'll get up on their hind feet, and they'll lean on the cactuses, and they'll stretch out their necks. And those ones with the longest necks could eat the longest, because they could eat as these things are growing, they could eat them at taller heights than a short-necked one. So the short-necked ones died out, and the long-necked ones lived because they could get more food. That's called survival of the fittest. Have you ever heard of that? That's part of Darwin's theory. There's me next to one of those tall cactuses. Look, I can't reach the food. I'm going to die. Yeah, see, I can't reach it, so I'm not going to get any food, so I'm going to die. Oh, but wait, I have a backpack on that has food in it.
Who took all these pictures?
That's where I beat the tortoises. Smarter. What's that?
Who took these pictures?
Friends of mine.
They're really good.
Heck yeah.
When was this?
2007, I think. 2008, something like that. There's me next to a short cactus. You find short cactuses like this on islands that have short-necked tortoises.
Or how does the tortoise eat it if it's really like pointy?
The young cactus pads don't have any needles on them, and the young pads grow off the old pads, and they could eat those. This island though has lots of food on the ground, grasses and stuff. So the tortoises don't even mess with the cactuses. They just eat food on the ground. So the cactuses didn't evolve to grow tall. What about the finches? Did we talk about that yesterday?
No, not really.
Darwin was a hunter and a collector, and he shot birds when he saw them, and he dissected them, and he measured them, and he put them in jars, and he put them in alcohol, and he took them back to England with him. He wasn't really a bird expert, but when he got back to England, he took all the birds that he had collected to a bird expert. And the bird expert looked at him and he said, "Guess what, Charles? They're all finches." And he was like, "Huh?" He said, "They all look different. Some of them have thick beaks, and some of them have thin beaks, and some of them have long beaks, and some of them have short beaks." I took that picture, by the way. Isn't that a good picture? I'm an incredible photographer. And he said, "How is it they have all these different sized beaks? How are they all finches?" And the guy said, "Well, I don't know. You tell me." And Darwin said, And Darwin had taken great notes. And he looked back through his notes, and he noticed that on the islands where the birds had real thick beaks, the only type of food that there was to really eat were nuts that had real thick coats on them. He had actually collected some of the nuts and had them in jars too. And he kept track of which island everything was on that he collected. So he was a real good scientist. And so he could go back and look what type of food there is on the island and what type of beaks the finches had. And he made the observation that on islands where you need thick beaks to eat, that was where you find the thick beak finches. And on islands where there was only insects or something like that, you got thin beak finches. And so Darwin had the idea that maybe the finches came to the island a long time ago and changed depending on which island they were living on. The beak sizes changed. That's his idea. He came up with how they changed. It's called natural selection. Well, let's talk about that now before we do artificial selection. So natural selection has 3 points to it. Point 1 is called variation. Variation means if you have a bunch of kids, they're going to be different. The kids will be different from one another. That's the idea of variation. Have y'all ever noticed that kids are all different? Y'all don't look all the same to me. Some of y'all are tall, some of y'all are short. Some of y'all have long necks, some of y'all have short necks. Some of y'all have big noses, some of y'all have smaller noses. Some of y'all have dark hair, some of y'all have light hair. Some of y'all have darker skin than others. Some of y'all have darker hair than others. Some of y'all have longer hair than others. There's a lot of variation in a population. That's part 1 to Darwin's theory of natural selection. Do you believe in part 1?
Yes, sir.
Variation, things have variation, yeah. Part 2 was overproduction. Overproduction means there are more born than could possibly survive. He noticed that a rabbit will have a whole bunch of baby rabbits. And all it takes is a little bit of math to know if 2 rabbits have 10 baby rabbits, and every one of those survives to adulthood, and each pair of those has 10 babies, you're going to be overrun with rabbits in just about 2 or 3 generations. And Darwin watched. A lot of things eat rabbits. And so there's an overproduction. There is more born than survive to adulthood. That's the second part of natural selection. Does that make sense? Not everyone survived. If everyone survived, we would be overrun with organisms in no time. There was a famous economist named Thomas Malthus that wrote about overproduction, and Darwin read his books. And then finally, Darwin said, well, if there's variation and there's overproduction, that means only some survive. Is it random which ones survive? Darwin said it's not random which ones survive. Darwin said the ones that are born with beneficial adaptations survive. And this is what's been called survival of the fittest. Have you ever heard that statement, survival of the fittest? Only the ones with the adaptations that are beneficial are the ones that survive. If you have a whole big population, and some have short beaks and some have long beaks, and some have thick beaks and some have thin beaks, if your population happens to be on the island that has real thick nuts that need to be cracked, and you happen to be born with a thick beak, you're more likely to survive than your thin-beaked buddy. And he dies, he doesn't get enough food, and you live. And you mate with someone else who has a thick beak because they lived. And if you have a thick beak and your mate has a thick beak and y'all have kids, guess how the kids are going to end up?
Thick beak.
Most of them will have thick beak. Now some of them will have thinner beaks than you had, and some will have even thicker beaks than you had. But for the most part, your kids are going to be thick beak because the parents are thick beak. So you pass that thick beak on to the next generation. So beneficial adaptations survive, and we can add to that and reproduce. And that's an important part of Darwin's theory. Beneficial adaptations survive and reproduce. And you can add something in here if you want to that Darwin wrote about. It's called heritability. Heritability. I think that's an A. Heritability. You can inherit the adaptations from your parents. That's what heritability means. So you will inherit you will tend to inherit your parents' traits. So if they had big beaks, you'll get big beaks. He wrote about all of this in his book. If it is true, if these 4 things are true, organisms will change and evolve. You can argue with these 4 things all you want. People have done that for 150 years, but no one's ever come up with any evidence that says that these aren't true. No one's ever come up with any evidence that says evolution doesn't happen. All the evidence points to evolution happening. And I'm going to show you a lot of that evidence in the coming chapters. If you could come up with some evidence that says this doesn't happen, you'd be famous and rich like that. They'd throw away Darwin's name and they'd say, oh, it's Lachlan. He came up with the new theory. Or whichever one of y'all does it. But for about 200 years now, they've never come up with anything that disproved it. So let me show you some of the evidence that we have that evolution actually happens. Have you ever heard of dogs? How many here has a dog? Most of y'all. I'm a dog guy. Some people are cat guys. I actually used to be a cat guy and I changed to a dog.
I have 4 cats.
You know why? Because I got allergic to cats.
I'm allergic to cats.
I became allergic to cats. I didn't used to be allergic to cats. We had a bunch of cats. I held them all the time, fed them. I liked the cats. And then all of a sudden after college, I was allergic to cats. Isn't that weird? But let me tell you something about dogs. You know how long dogs have been around?
Thousands of years.
12,000 years. Why do I say that? If you look for dogs in the fossil record, you find plenty of dog fossils. But as you go back in time, the dog fossils start looking more and more similar. And they start looking more and more like wolves. And if you go back to about 12,000 years ago, you will not find any dog fossils anywhere in the fossil record. If you find one, you'll become rich and famous. But there aren't any. All dogs are descended from wolves. And there were wolves about 12,000 years ago. Most wolves don't like people and they won't hang around people, but there were a few born that kind of didn't mind people. And they would hang out near the people. And they would eat off the people's scraps because people threw their trash out and these wolves would come in and eat the scraps from the people. And then the people started noticing those wolves, and maybe one of the wolves was timid enough where someone could pet it. And now you have dogs starting. And humans have been breeding dogs ever since those first wolves started associating with people. And humans would take the smallest one and mate it with the smallest one, and they would have a litter, and some of them would be even smaller than their parents because of variation. And if you keep mating smaller and smaller wolves, and you get smaller and smaller, eventually you get something that's not even a wolf anymore. We call it a dog. And why do we want small dogs? Well, they were real good at crawling into holes and eating rodents that would come and raid our grain supplies that our human farmers were storing. And it was good to have dogs and cats around that would eat all the rats and mice and things and keep our grain storages clean. That's what started breeding dogs, because they were useful and they were helpful. And you could breed dogs to defend you. And you could breed dogs to help you hunt. And so we've been doing that for many years. We call it artificial selection. Artificial selection is taking something and breeding it and changing it. And we have changed the wolf into a dog over time. We have created this species by what's called selective breeding. Did you know there's a type of dog now that cannot even mate on its own without human intervention? Have you ever heard of a British Bulldog? The only way British Bulldogs can mate is if they're held by humans in the mating position. What if that was your job? To mate British Bulldogs. You have to hold them while they're doing it. And you got to get it, because they can't get in that position on their own. That is not a natural organism, the British Bulldog. It is a human-made species.
So I could tell my dog I'm his god.
If you have to hold it for it to mate, yeah, probably so. This is a little video footage on that. This is my favorite scientist, Carl Sagan, talking about artificial selection.
This process is called artificial selection.
I don't ever watch it.
In the case of the Heike Crab, it was affected more or less unconsciously by the fishermen, and certainly without any serious contemplation by the crabs. Humans, for thousands of years, have deliberately selected which plants and animals shall live. We're surrounded with farm and domestic animals, fruits, vegetables. Where did they come from? Were they once free-living in their present form in the wild and then induced to adopt some less strenuous life on the farm? No. They are, almost all of them, made by us. The essence of artificial selection for a horse or a cow, a grain of rice or a Heike crab is this. Many characteristics are inherited. They breed true. Humans encourage the reproduction of some varieties and discourage the reproduction of others. The variety selected for eventually becomes abundant. The variety selected against becomes rare, maybe extinct. But if artificial selection makes such changes in only a few thousand years, what must natural selection, working for billions of years, be capable of? The answer is all the beauty and diversity in the biological world.
Carl Sagan is famous. He made a lot of educational videos when I was y'all's age. He made a series called Cosmos, which is still shown today. And Neil deGrasse Tyson, if you've ever heard of him, he remade that video series recently. Let me tell you the story. At the beginning of that, he was talking about the Heike crab. Let me tell you the story of this crab. At a place in Japan, there is a story about some samurai soldiers. Kobe, you with me here? What's going on? You okay?
Yeah, sorry.
Place in Japan, there's a story about some samurai warriors that were surrounded, and if you're a samurai, you can't be captured, so they threw themselves on their sword, and they fell into the ocean. And the story is that their souls still live today in the crabs that crawl around the area and survive in the area. And if you catch a crab who has markings on its back, here's a crab. Y'all know what a crab is, right? I'll draw a little crab for you. The crabs in this area have backs, and there are markings on the back. And if you catch a crab in the area, you got to look at its back. And if it has just normal markings, you can eat it. But if it has some markings that look kind of like a face, you got to throw it back. Because if it has markings like that in it, it's one of the surviving souls of the samurai. And you got to throw it back.
What happens if you eat it?
Nothing. It's just myth.
Do the people in that area hate you?
Yes.
Do they what?
Will they hate you if you eat it? Like
Yeah, right. It's the legend is you shouldn't eat those. And so people throw them back if they catch them. Well, this has been going on for thousands of years. They've been eating the ones that don't look like faces, and they've been throwing the ones back that do look like faces. This is artificial selection at work. So after doing that for 1,000 years, all the crabs in the area, they have created a new species of crab who has a back that looks like the face, like a face. And it's not only a face, it's a face of a samurai. And this is it. It's called the Heike crab. The back of it has a face of a samurai. Eyes, nose, mouth. How cool is that? This didn't used to exist. This wasn't something that's always existed on the earth. This is something that has been made by humans. We call that artificial selection. That's the Heike crab. It's a species of crab.
How was it made by?
Did you hear the story I told you about the...
Yeah, but I mean that's just.
Humans have thrown back, if it has markings on its back that look like a face, the humans have thrown it back. And so those survive. Markings like a face survive. Markings not like a face are killed. We have selected the ones that look like a face. Does that make sense?
Why would they not eat, why don't they kill the ones with faces though?
Because the story goes, if it has markings like a face, you don't eat it. Because it's got the soul of a samurai in the crab.
That's scary.
Yeah, does this make sense to y'all?
Mm-hmm.
Artificial selection is what they call it. Artificial selection. Did you know we've been selecting cows with big udders to be the ones that mate? And we've been doing that for the last 100 years?
Why?
Because a cow with a big udder produces more milk than a cow with a small udder. So we've only been letting the cows with the big udders mate. Did you know a cow udder is 10 times as big as it was 100 years ago? 10 times. It holds 10 times as much milk. Farmers have been measuring this very accurately for 100 years.
I bet they're happy.
That's not natural for the cow to have this giant udder. We have made that by selectively choosing which cows mate. Horses the same way. Did you know we've been breeding bigger and faster horses for several thousand years now? The natural wild horse of several thousand years ago wasn't this enormous thoroughbred that we have now. They were much smaller, much slower. Their legs didn't break as easily. We have bred them so that their legs are thin, and that makes them faster. And horses break legs all the time now when running. Have you heard that?
Mm-hmm.
Don't they have to be killed if they break a leg?
They do. They don't heal. The natural, normal horse of several thousand years ago, the wild horse, not big and fast and thin-legged like that.
Wouldn't you want a horse that isn't going to break its legs so it lives?
What if your horse is faster if it has thin legs but has a small chance of breaking it? Would you rather have that if you're a horse racer?
Yeah, I guess.
Yeah, you probably would.
Aren't they fairly short to get a horse racer?
You mean a jockey?
Yeah. Aren't they like super short?
Well, they want somebody light so it doesn't slow down the horse much. So most people that are real light like that are short. There's no 7-foot jockeys that I've known. I should have been a jockey.
You could have been.
I rode a horse when I was about 8 and it just took off. It scared me to death. And I couldn't stop it. It was just running and nothing I did stop it. And it finally stopped on the other end of the field. And the person running this camp where I was finally caught up to me and got me off the horse, and I never rode again. It scared me too. Yeah.
You should ask Asa about riding a horse.
Oh yeah? What happened to him? Same thing?
A little
Did he
different.
get thrown?
He was riding on the back and it took off. He was riding it bareback and he hit the ground and got a concussion.
You could die from a fall of a horse. Scary.
Christopher
Christopher Reeves.
My dad.
Your dad broke 6 ribs?
Riding bareback. And then I broke 2 ribs.
Did y'all ever see the movie Superman, the original? That guy died from a fall of a horse. Well, he got paralyzed and he's dead.
Alex Dunn's face got stepped on by a horse.
Stepped
Yeah,
on?
her whole cheek came off.
Really?
That was like 2 years ago.
Horses didn't used to be that big. Artificial selection. So Darwin wrote this book, The Origin of Species. He outlined his entire
That one's good.
theory. Did I show this book to y'all last time? He outlined his entire theory. He had 30 years before he published it. In 30 years, he came up with all this evidence of evolution. He showed how pigeons evolve. He showed how all these organisms on the bonobos might have evolved. He talked about how giraffes evolved. He talked about how all these different species of plants probably evolved. And we have all kinds of other evidence that we've got since then for evolution, and that's what we're going to go over in the next several chapters. We're going to talk about all the different evidences of evolution and kind of how evolution works. There's a lot more to it than I've talked about so far. Yeah?
Do you think giraffes had short necks? Like a long time ago?
Yes, giraffes at one point didn't have long necks. Ancient giraffes looked kind of like horses. But they found themselves in an area where the only food was high up on trees. And they could just barely reach it. But if you were born with a little longer neck, you had plenty to eat. If you were taller than all your buddies, and you're a giraffe, you could eat away. But if you were shorter, couldn't quite reach it, you didn't eat as much. And so you didn't live as long, you didn't have as many kids, that sort of thing. And over the years, that produced longer and longer necks. And it is true, if you go back through the fossil record and you look at giraffe fossils, the longer ago you find the fossil, the older the fossil is, the shorter its neck is. And if you go back about 20 million years, giraffe look a lot like a horse. Not a very long neck. Still a pretty long neck, but not. Horses have long necks, but not like today.
Or a zebra is just like a type of horse. Not
A zebra is a type of horse. Zebras are closely related to horses. We can find evidence of evolution in every animal we look at. Every animal has changed. Not just like a few have changed. They've all changed. And plants. Every one of them, if you look at the fossil record, used to be different. Yeah?
Haven't horseshoe crabs like stiff?
Horseshoe crabs haven't changed much. You're right. And alligators haven't changed much. But they have changed. Just not much. So they call horseshoe crabs and alligators, they call them living fossils. Because they're very similar to how they were a long time ago. They just haven't. Sharks haven't changed much. But they have changed.
I think alligators have gotten smaller. I think so.
I don't know. It's a good question.
Maybe alligators dinosaurs. Just like little ones. Oh, they were?
Yeah.
Did you just say that?
Yeah, alligators were alive at the time of the dinosaurs, and they are related to the dinosaurs.
So we're
They are thought to have survived because they bury their eggs in the mud. And it is thought that when the meteor hit the Earth, they killed all the dinosaurs. We're going to study that too. That it got real cold. It got real hot first with all the fire from the meteor, and then it got real cold with all the smoke in the atmosphere blocking out the sun. And the only way to survive real hot and then real cold is if you're buried in the mud. And probably all the alligators and crocodile adults died. But the eggs that were buried in the mud survived and hatched. And the alligators and crocodiles made it.
How long were they
Is
in
that
the mud?
next chapter?
They'd have to be there for a few years to get over until the dust settles and the sun comes back out. The eggs were buried in the mud. The eggs.
How would they be able to hatch? Wouldn't they be a year
When the
old?
temperature gets right, they can hatch.
Okay.
So they can lay dormant for 2 years?
Yeah.
That's cool.
That might have been what saved the alligators and crocodiles.
Is that next chapter?
Yeah, we're going to talk about all this stuff more in the next several chapters. Yeah.
What did butterflies evolve from?
Okay, so butterflies are insects. And they're arthropods because they have an exoskeleton, which means their ancestors were probably in the ocean as crabs, lobsters, shrimp, those sort of organisms that live in the ocean. And some of them came onto land and evolved into insects. And a butterfly is an insect, so its ancestor is an insect.
I thought it came from pterodactyls.
No, totally unrelated, even though they both have wings. No, that's something we'll talk about. They're called analogous structures. They both have wings, but the wings evolve separately in each line. Insects have wings. Pterodactyls had wings, but they evolved those wings separately from one another. We'll talk about that too later. Okay, well the bell's about to ring, so have a great Thanksgiving. Make sure sure you read your chapter. Hey, you might want to write your essay in advance. Those of you who are doing poorly, write your essays in